and reflection, not dilation. Dilation makes similar because it gets bigger or smaller, not the same size. All right. Now, before we get into all the congruency stuff, we first need to talk about some theorems with triangles. Now, most of these you've probably heard of before. All right. Some of them you may not have, and we'll talk about that today. So here's my goal for today. My goal is to get through 2.1 and at least some of 2.2. All right, because we do have an extended first period today, and I only have like 2 juniors in this class. All right. And then whatever time we have left, I'll give you time to do work. All right. And if you did not finish the test yesterday, that time is when you're going to go finish the test. So I'm shooting for to give you guys at least a solid 40 minutes to do work. All right. So go ahead and go to page 2 of your new packet. Also, before we start, you're definitely going to want a calculator. So if you have not grabbed one yet, grab it. Yes, ma'am.
I got you. This might be.
Yeah. All right, so before we get into some triangle theorems, first let's do some basic geometry review. So an angle is formed by 2 connecting rays that share the same endpoint. So in other words, if I draw one ray, and if I use that same endpoint, draw the other ray, it creates an angle. A vertex is the common endpoint shared by 2 rays for an angle. So this point right here is your vertex. Straight angles. Does anyone remember how many degrees a straight angle is? It's 180. So a straight angle is literally a straight line. So a straight angle is 180 degrees, so it looks like this. That's a straight angle. Now, congruent angles. What do you guys think a congruent angle is? What will make 2 angles being congruent? They're the same what?
Length.
Not length. Go deeper. They're the same degree. All right, so they're the same measure. So it's 2 or more angles that have the same degree of measure. Now, remember, congruent angles. For example, let's say I had 2 angles here. Typically, an angle is named using 3 points. So let's call this point A, B, and C. And then we have another angle. Let's call it D, E, and F. Now, typically, if you see an angle marked with the same number of ticks as another angle, that typically means congruent. Which, by the way, a little equal sign with a squiggle over top, that means congruent. And the way we would write it, so the way you write an angle name is that you always put whatever the vertex point is in the middle. So that should be the middle letter. So in other words, I could either write the first angle as ABC or CBA. It doesn't matter as long as B is in the middle. I cannot name this angle BCA. That's a different angle. All right. So whenever you name an angle, the vertex has to be the center letter. So I can say that angle, which by the way, this just means angle, ABC is congruent to angle DEF. Now, angle bisector. So, bisector, what does that sound like to you? So, think about the root of the word bisector. What comes to mind? 2. All right? That's exactly what it means. A bisector, an angle bisector is a segment that bisects or cuts an angle in half. And by half, I mean 2 congruent pieces. So, for example, this purple line right here is an angle bisector. So if I name this angle, let's say it's ABC, and let's call the bisector D. All right. What it does is that it creates 2 congruent angles. So this little angle is the same measure as that little angle. It cuts it in half. So in other words, angle ABD is congruent to angle CBD. You can also say that angle ABD is the same thing as half angle ABC. Meaning that, let's say that this entire angle measure was 60 degrees. That means this little angle is what? So let's say this big angle, so the blue angle, is 60 degrees. So one little piece of it would be 30. It cuts it in half. Right? Does that make sense? An angle bisector does. It literally cuts in half. So if you ever hear the word bisector, whether it's an angle bisector, a segment bisector, whatever, it just means it cuts it in half. All right, adjacent angles are 2 angles that lie in the same plane. They have a common side and a common vertex. So, for example, all right, let's say that I had angle 1 and angle 2. All right, angle 1 is adjacent to angle 2 because they share the vertex and they share a common side. So adjacent means they share the vertex and they also share a side. Now, adjacent does not necessarily mean congruent. All right? More often than not, they're not. So don't assume if they're right next to each other that they're congruent unless they state that the middle line is an angle bisector. All right? That's the only case in which they're congruent, or which adjacent angles are congruent. Vertical angles. They're two non-adjacent angles formed by two intersecting lines. Now, does anyone remember what's true about vertical angles? So, vertical angle is if I draw two lines. All right. These two angles, so let's call this 1 and 2, are vertical angles. And these two angles, let's call them 3 and 4, are also vertical. Now, does anyone remember what's true about vertical angles? Specifically, their angle measure. What's true about vertical angles? Vertical angles are always what? They're congruent. Good. So, in other words, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Now, if you notice, I marked 1 and 2 with 1 tick mark and 3 and 4 with 2. That was on purpose. All right? When it comes to congruent angles, a lot of times it's a matching game with tick marks. So, in other words, if you see an angle marked with 2 tick marks and another angle marked with 2 tick marks, that means those two angles are congruent. All right? If you see one marked with 1 and the other one marked with 1, they're congruent. So in math, if we have multiple sets of congruent sides or angles, the way we figure out which ones go with which is that we just mark them with a specific number of tick marks. All right, and then it's just a matching game. Now, linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So, linear pair, they look like this. So let's call this angle 1, angle 2. Now, does anyone remember what's always true about a linear pair? What's true about the angle measures of a linear pair? First off, what does this look like? Like, if just judged from my picture, what does it look like they'll be? They look like they'll be supplementary, which means they'll do what? Add up to 180, and that's exactly what they are. They're supplementary. So linear pair, they're always supplementary. So angle 1 plus angle 2 is equal to 180 degrees. So just know if you hear the phrase linear pair, they're talking about two supplementary angles. And a linear pair looks like the stereotypical supplementary. All right, it's not just two angles out in space that we know to add up to 180. All right, they will actually look like what you've been seeing as supplementary your entire schooling. Now, we already said supplementary is two angles whose sum is 180 degrees. What's complementary? It's two angles whose sum is what? 90 degrees. So complementary is 90, supplementary is 180. Now, triangle sum theorem. This is probably the easiest triangle theorem to remember. It's basically saying that if you add up all three interior angles of a triangle, meaning all three angles inside of the triangle, what would it equal? 180. That's all it's saying. So all the triangle sum theorem is the sum of all three interior angles of a triangle is equal to 180 degrees. So if I drew me a triangle, remember the word interior, when you hear the word interior, what do you think? Inside. The reason I'm explaining that part is because you will hear the word exterior, interior be mixed in a lot. So make sure you know the difference between the two. So if you hear the word interior, I'm talking about inside the figure. So let's say I got the three angles inside the triangle. Let's just label them 1, 2, 3. If I added up all three angles together, okay. No, you're good. Describe the new packet. So if you add up all three of those angles, they should equal 180 degrees. So let's do some practice with that. Let's look at this very first example. They gave us two angles, and they want us to find the third. So what do you think I'm going to do? Add them up and subtract them from 180. So I'm going to add up 65 plus 57, which is what? Is what? 122. So those two equal 122 degrees. Then I'm going to take that and subtract it from 180, which would give me what? Say that one more time. 58. Yeah, 58. So this angle right here is 58 degrees. Now, look at this next one. Got some things going on here. So they only gave us one angle inside the triangle, but we can use what we know about angles to kind of work our way to the one they're trying to find, which is right here. So for all intents and purposes, it's that angle right there. Now, and by the way, the 35 goes with this angle. So where would be a good place to start? Where's some place that we can kind of tell, like, okay, some angles congruent or some angles supplementary, or what can I do? What's congruent? Right here, what is this? What type of angles are these two? They're congruent, but how do we know they're congruent? What are they specifically? Two intersecting lines. They're vertical angles. So, because they're vertical angles, that means these two angles are congruent, so this angle's 35 degrees. And again, that's because they're vertical. Now, I have enough information to find this angle. How? How can I find the green angle? Right, triangle sum theorem. So add 100 plus 35, subtract that from 180. So 100 plus 35 is 135. So what's 180 minus 135? It's 45. Now I can then use that last one to figure out the orange angle. So what's the relationship between the green angle and the orange angle? So if it helps, maybe turn your paper. What does it look like? So my suggestion, turn your paper so that this line looks like this. They look like they're supplementary. So it's hard to see because it's on its side, but if you turn your paper and you look at it from a different angle, no pun intended, it does look like a linear pair or set of supplementary angles. So this set right here is a linear pair, meaning they're supplementary. So how do I find what the orange angle is? Subtract what? So they're supplementary. What does that mean? Supplementary means what? They add to 180. So if I know that the 45 degree and the orange angle add to 180, what do I need to do? Subtract 45 from 180. That'll give me what? 135 degrees. So that orange angle is 135 degrees. So guys, a lot of times with these, it's like a big puzzle. All right. When you're finding angles and triangles, sometimes they don't give you a straight path to what you're trying to find. You kind of have to work your way around. All right, so find a place to start that makes sense to start, like at the vertical angles. You're like, okay, these are verticals, so I know they're congruent. Like, okay, now I got two angles of the triangle, so I can find the third. Oh, look, now they're supplementary, so I can find that one. All right, sometimes it's not going to be a direct path. All right, let's look at some where we kind of have to do a little bit more work with it. So look at part 2. All right. So for this, all these problems we're solving for x. Now, we're still using the theorems that we already know. Okay, so what theorem do you think I'm going to be using for this one? If I want to solve for x, what do you think I'm going to do? So we got 3 angles on a triangle. Where are those angles? Are they inside or outside of the triangle? Inside. So we got 3 angles inside a triangle. So what do you think we're going to do? Triangle sum theorem, which states what? All the angles add up to 180. So we basically just said what we're going to do. What do you think I'm going to do? Add up all the angles, set it equal to 180. So that's how you're going to set up your problem. You're going to add up all the angles. So 55 plus 54 plus x plus 74. You're going to set it equal to 180. Because we know that all 3 of these angles added together should equal 180. So, difference between geometry and algebra. A lot of times geometry, you have to use what you know about a shape in order to do the algebra. All right, algebra, they'll just already give you the problem until you solve it. Geometry, you have to take what you know and then set it up. All All right, so that's why a lot of times people don't like geometry because of that extra aspect. All right, so you need to really think. Don't be daunted by a problem like this. It's actually a pretty simple problem once you get it set up correctly. The problem is how to set it up. Okay. So now that I got an equation, what do I do next? We need to combine like terms. So I need to add up the 55, the 54, and the 74. So I'm going to bring the x down. What's 55 plus 54 plus 74? 182. What's my next step to solve for x? Yeah. 55 plus 54 plus 74. What is it? Okay. I just said the wrong thing. I'm deaf, y'all. You got to use your louder voices. I'm not actually deaf, but yeah, I just can't hear. All right. So what's my next step to solve for x? Subtract 183 to both sides. So what's 180 minus 183? -3. Now, you may be thinking, well, we got a negative number, so that has to be wrong. It's not. Because we're solving for x, not solving for the missing angle measure. So x can be any number we want, as long as whenever we plug it back in and we evaluate, it should not give us a negative number. So if I plug in -3 for x, what's this angle measure actually? 71. All right. So they just asked us to solve for x. So if they just ask you to solve for x and you get a negative number, don't be thrown by that. It could possibly be a negative number because they're not asking us to find the actual angle measure. All right, let's try another one. Try this one on your own. So it's the same process that we just did. So I'll leave that up just for reference. Everyone's pencils up and moving. So it's almost the exact same process as what we just did. All right, thumbs up if you're ready. I'm gonna give you one more minute. All right. So before we go over it together, what I want you guys to do is take about a minute, talk with your group mates, compare answers. Compare work, compare answers. So talk with your group mates, compare answers. Uh-huh. Right now or okay, yeah, that's fine. All right, we're gonna come back together in 3, 2, 1. All right, so let's go with group 3. So group 3, explain how you set it up.
We did 70 plus 60 plus 8.
Okay, and
70, 60, and 2. We got 132.
okay, and
Subtract 132 from 80. We got 8x.
okay, and
8x.
8x equals 48. There's one more step. Solve for x. And do what? Divide by 8. Good. So 48 divided by 8 is what? Good. So that's how you would set it up, and that's exactly how I did it. So add up all three angles, set equal to 180, combine like terms, and then it's just a two-step equation. All right, any questions so far? All right, one more, and then we'll move on. So this one we're going to kind of do together. It's a little bit of a thinker. All right. So for this, we're actually solving for whatever the angle measure of angle A is. So by the end, we should get an angle measure there. Now, the problem is that angle A currently has an expression there with an x in it. So logically speaking, what should we do first? So before we can get the angle measure, we first gotta do what? Solve for x. All right. Now, this problem is actually pretty similar to what we've been doing. There's just a little bit of finagling here. So we don't have three angles right now within the triangles. We can't just set it equal to 180. But how can I make it so that we have all three angles? I'll give you a hint. It deals with this angle right here. What's true about that angle and the one that we're missing within the triangle? They're congruent because they're vertical. So this angle is also 4x plus 17. So now we got enough, all three angles of the triangle. So we're just going to do what we've been doing. Add up everything, set it equal to 180. So 4x plus 17 plus x plus 23 plus 80 is equal to 180. Now be careful with these because there's a little bit more combining of the like terms because now there's two sets of like terms. So there's the constants. So that's 17, 23, and 80. But then there's also the x's. So remember, when we combine like terms with variables, what's the only thing that we're adding? So 4x plus x would be what? 5x. You only add the coefficients, which is the number in front of the variable. And there is no number in front of the variable. The unspoken number is 1. All right. So if I do 4x plus 1x, it's 5x. What's 17 plus 23 plus 80? It's 1 what? 120? Okay. I got this thing in my ear. I can't hear. Then we subtract the 120. So I get 5x is equal to 60. What's my last step? Divide by 5. What's 60 divided by 5? 12. Now, that is not our answer, because what did it ask for? It asked us to solve for A, angle A. So we're trying to find this angle right here. But we just completed the first step. So this right here was the first step. We had to solve for x. So first step, solve for x. So what's my next step? I take my x value, plug it in to the expression for a. So I'm going to take this x equals 12, and I'm going to plug that 12 in for x. So your second step is plug x back in and evaluate. Which all evaluate means, just to kind of recall the vocab, all evaluate means is do the order of operations. All right. So angle A is equal to 12 plus 23, because I just replaced this x with 12. So what's the measure of angle A? How many degrees? 35 degrees. So angle A is 35 degrees. So the actual measure of this angle is 35 degrees. So I can tell you right now, if this was on a test, I would throw one like this at you, where a lot of people solve for x and then stop. All right. And if it was a multiple choice answer question, I would guarantee you that whatever x is equal to would be part of your multiple choice selections. But you got to read. If it says solve for an angle measure, you got to plug x back in. All right. So be careful with those. Any questions on triangle sum theorem? All right. Now, let's look at the next page for a different theorem. This theorem is called the exterior angle theorem. Now, exterior angle theorem. So when you hear the word exterior, what am I talking about? Outside. So we're talking about an angle outside the triangle. So an exterior angle theorem, it's the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Yes. Now, that's a lot of big words. You may not know exactly what it means. But what it means is if I drew a triangle with a little line outside of it, all right? This angle right here, let's call it 1. 1 is your exterior angle. So this angle 1 is the exterior angle because it's where in relation to the triangle? It's outside of it. Now, I'm going to label the other angles 2, 3, and 4. Now, if I'm talking about the non-adjacent angle to the exterior angle, what two angles are not next to the exterior angle? 2 and 3. So, these angles are the non-adjacent interior. They're not sharing a side with the exterior angle or a vertex. So non-adjacent interior angle. That's what those two are. So all this theorem is saying is that if you take the measure of angle 2 and add it to the measure of angle 3, that'll equal the measure of angle 1. So if you take these two non-adjacent angles, add them together, that'll give you the measure of your exterior angle. Now, that is the exterior angle theorem. So to put it in kind of layman terms, if you add up the non-adjacent, so the two non-adjacent interior angles, that equals the exterior angle. So the sum of the two non-adjacent interior angles is equal to the exterior angle. So this is just a fancy way of stating what we just said with the triangle. Now, another great thing about the exterior angle theorem is, what's true about angle 1 and 4? What's true about angle 1 and angle 4? They're supplementary. So sometimes if you don't have enough information to use the exterior angle theorem, you do have enough to at least just use what we know about supplementary angles, which is just angle 1 plus angle 4 is equal to 180 degrees. All right, let's do some examples. So look at number 1. They're having us find the exterior angle. Now, did they give us the two interior angles that are not adjacent to the exterior angle? Yes or no? Yeah, they did. So this angle would be the adjacent angle. The other two are not. So what's the only thing I got to do to get the exterior angle? Just add them together. So I'm going to do 105 plus 35. That's equal to what? It's equal to 140. So this angle right here is 140 degrees. Now, to see if that's true, let's find this little angle right here. So if we use triangle sum theorem to find the third interior angle, what would it be? So add these two up, subtract from 180. So if you do 180 minus 140, what is it? 40. So this little angle is 40. Is it not true that 140 and 40 equal 180? Yep. So that also holds the fact that these two angles are supplementary. So that's a way you can check yourself. All right. If you find the interior angle, these two angles should be supplementary. Now, what happens if you're trying to find one of the interior angles and they give you the exterior? Right. So these two angles still add up to this angle. So these two angles will add to this angle. So in other words, I would take that exterior angle and do what? Subtract 82. So what's 146 minus 82? 64 degrees. How are we feeling about the exterior angle theorem so far? All right, now let's do some where we actually gotta throw some x's in there. So let's look at number 3. So they gave us the two non-adjacent angles and they gave us the exterior angle. So using what we know about the exterior angle theorem, how would I set up my problem? So think about what we just did in the previous examples. That's going to kind of guide you to what we're doing now. So we're going to start by adding up these two angles. So 6x plus 2 plus 50. What's it going to be equal to? Someone besides Bella. So we added up these two angles first. But what do we know that this sum is going to equal to? Not 180. It'll be equal to the exterior angle, which is 13x minus 4. So we'll set this equal to 13x minus 4. So what do I do first? Combine like terms. Only like terms are on this side, so that's 6x plus 52 is equal to 13x minus 4. Now what do I do? Gotta get the x on one side, right? So how do I move an x over? I'm just going to subtract one of them over. I typically subtract the smaller one, so I'm going to subtract the 6x, just so we're not dealing with negatives. So 52 is equal to 7x minus 4. And now we got ourselves a nice little two-step equation. So what's my next step? Add 4. So 56 is equal to 7x. What's my last step? Divide by 7. So what's x equal to? 8. Now, if you have any doubt in your mind that you did something wrong, my suggestion is plug it back into for both x's, all right, and then see if you evaluate if when you add up these two expressions, it'll add to whatever this number is. So for example, 6 times 8 is 48, plus 2 is 50. 50 plus 50 is 100. So whatever I get here, this should be equal to 100. 13 times 8, that's 104, minus 4 is 100. So 100, 100. So it works. That's always a good way you can check yourself. All right, last one for exterior angle theorem. Look at number 6. Now, pretty much the same process that we just did, except there's one extra step. What's the difference between what we just did and what number 6 is asking of us? Kind of. What's it asking us to find? An angle measure. So HDC. So HDC. So we're finding this angle right here. So in other words, once we solve for x, what do we have to do last? So what did I say previously with interior angles? If they ask you to solve for an angle, but you have to solve for x first, what's your last step after you solve for x? Plug it back in for the designated angle and evaluate. So what I want you guys to do, take a minute on your own, try number 6. So I'll leave this one up for reference, at least for the solving x aspect. But remember, once you finish, plug it back in to this angle right here. Solve. So you see all the pencils moving. Solving for X setup is very similar to the one we just did. That's why I looked it up there for you guys. And then you guys got to take it a step further. After you solve for X, you got to plug it back in for the designated angle and find that angle measure. Thumbs up if you're ready. Okay? Take a minute, talk with your group mates, compare answers.
Well, class is short because you have 2 hours for three.
Second period's like 10 minutes less.
Oh my.
And then they also shorten lunches a little bit. So it's fourth lunch. So each lunch is going to be 20 minutes long.
20 minutes. Well, this is food just fancy. I'm gonna say 20 minutes to eat.
All right, so talk to the group mates, compare your answers. If someone struggled, maybe help them out. All right, we're gonna come back together in 3, 2, 1. All right, so let's go group 7. How do I initially set this up? Good. So 13x plus 60 is equal to 11x plus 13. All right, group 2. What'd you do next?
I got 6x. I combined my terms and I got 6x plus 73. Yeah, 6x plus 73 equals 11x plus 13.
Good. All right, let's go group 9. What'd you do next?
I just don't know social. Oh, 13 minus 7.
Okay, you can go with that route first. So 13 subtracted over. So 6x. Okay, so you did both at the same time. So you subtracted 6x to both sides, subtracted 13 to the other side, so you get the x on one side and the constant on the other. That you can go that route. So that would be 60 is equal to 5x. All right. Group 5. What was your next step? So from here, how do I finish up solving for x? You divide by 5. So what's 60 divided by 5? 12. Good. All right. Lastly, how do I finish it up? Let's go group 1. How do I finish it up? So I solved for x, but I haven't answered the question yet because I need to solve for the angle. So how do I get the angle that I'm finding? Right, we plug it back in for x. I'll do 11 times 12 and then add 13. So what's 11 times 12? 132 plus 13. That's 145 degrees. All right, so here's what we're going to do. I'm going to give you guys a 5-minute break. When we come back, we're going to start 2.2. We just finished 2.1. All right. For my people going to the Blitz, you guys have to go. The bell technically rings at 9. So once the 5-minute break's over, just hop on over. Go. All right. So if you need to use the restroom, you can go do that, or you can just stay in the classroom and chill for a second. Do not walk the halls and be quiet in the halls. There's other classes.
So this section only got 2 juniors. Marshall.
With Marshall.
It's Marshall. I'm not. I said, every day.
Where's the Taylor?
Who gave you that? The usher?
All right.
Who? You.
I'm just gonna say. I'm just kidding. Go work. She here.
What is it?
I need to see this one. That's the one. He said, did you get your phone back? Yeah. Parts. I thought you were We'll never find out. It's going to Black Friday.
Yeah, no. It's December.
No.
I swear.
Why?
Face food.
That's bad.
But you did.
Jerry.
When we gonna be done for today?
Huh?
When we gonna be done for today?
I want to at least get.
I know, but with the rest of
I want to at least start 2.2. At least get through the first part. Yep.
I did my test. I don't want to go back.
Gonna have to do your test. So.
Over there?
he wants to do it. He's doing this. He just wants to do it.
I don't even have your test. You have to go to you can get your test. She still has it.
It's kind of neat. Other specs. You can't even be chewing gum. Yeah.
All right, guys. So let's come back together. I'm on page 5. I want to get at least a little bit into 2.2, just so we're at a decent stopping place for tomorrow. Okay. So again, I told you I would give you about 40 minutes. So we'll just see how far we get. All right. All right. So 2.2 is more triangle theorem. So we've already talked about interior angle theorem and exterior angle theorem. All right. Now, the next parts of these theorems deal with how you identify triangles. So there's 3 types of triangles. There's scalene, isosceles, and equilateral. All right. Does anyone remember what it means for a triangle to be equilateral? It's kind of in the name. So equal, but if a singular triangle is equilateral or equal, say one more time. 360 angles, so all angles are congruent, which also means that all what are congruent? All sides are congruent. So equilateral just means that all sides are congruent. So if I were to draw a picture, all three sides would have the same tick mark on them. And just like Rajan said, in equilateral, all angles are congruent, which, since all angles have to be congruent and still follows the triangle sum theorem, meaning they have to add up to 180, you divide it by 3, you do get 60. So in other words, all the angle measures would equal 60 degrees. So if I have an equilateral triangle, 60, 60, 60. Now, that's equilateral. Does anyone remember what an isosceles triangle is? What's true about the sides and angles of an isosceles? So equilateral's 3 sides are congruent. Isosceles would be what? 2 sides congruent. All right. So an isosceles, 2 sides are congruent, as well as 2 angles. All right. 2 sides are congruent, 2 angles are congruent. So if I look at the triangle, 2 sides would be marked congruent, and the opposite angles of those 2 congruent sides would also be congruent. What about scalene? So I'll give you guys a hint with scalene. Scalene is any other type of triangle. So if I'm talking about side lengths of a scalene triangle, we already got 3 sides congruent, 2 sides are congruent, so what did that leave us? None of them are congruent. So scalene is literally just no congruent sides or angles. So it would just be a triangle like we know. Let's say this was 3, this was 4, and this was 5. Those are the side lengths. All 3 sides, not congruent. And so if all the side lengths are congruent, there's no congruent angles in there either. So these are the 3 main classifications of triangles. You classify by their sides. But you take it a step further. You also classify by their angles. All right. Now, the most typical type of triangle is an acute scalene, which all that means is that if it's an acute triangle, all 3 angles are acute. Which, what does an acute angle mean? It's smaller than 90, so less than 90. So all 3 angles are acute. In other words, they're less than 90 degrees. So that's the most typical type of triangle. So that can just be any stereotypical triangle. Let's say that this was 60, this was 50, which means that would be yeah, 70. Now, think about what you know about a right triangle. What makes a right triangle a right triangle? It has a 90-degree angle. How many 90-degree angles? 1. Well, 3 times 90 is 270, so it wouldn't fit the triangle sum theorem. So, a right triangle has 1 right angle. That's how you know it's a right triangle, if it has 1 right angle. Remember, right angle, that means it's equal to 90 degrees. And remember, that's typically dignified with that little box. So if you see that box representing the right angle, If it's in the triangle, it's a right triangle. And then lastly, obtuse. So an obtuse triangle has one obtuse angle. And what does obtuse mean? It's greater than 90. So, for example, let's say this was 120, 30, and 30. So not only did I draw an obtuse triangle, what type of triangle is the one that I just drew? So not only is it an obtuse triangle because of that obtuse angle, it's also what? It's isosceles because it has two congruent angles. So typically when you name a triangle, you name it by its type of angles first and then its sides second. Now, if it's an equilateral triangle, it's not going to have acute, right, or obtuse in it. It's just equilateral. Equilateral is the only exception. All right. So equilateral, it's just equilateral. Equilateral, that's the only exception. You just call it what it is, which is equilateral. It just means everything's equal. So the way you would say it is acute scaling, right scaling, obtuse scaling, acute isosceles, right isosceles, obtuse isosceles. All right, that's how you would name a triangle. Any questions on the naming of triangles? Now, just a review of the theorems. Triangle sum theorems just means that all angles add up inside the triangle add up to 180. So if I have a triangle, let's call angle 1, 2, 3. Angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Exterior angle theorem, we already discussed that. If we had a triangle, all right, let's say 1, 2, 3, and then the exterior angle's 4. Which two angles add up to angle 4? 2 and 3. So angle 2 plus angle 3 is equal to angle 4. That's exterior angle theorem. Now, third angles theorem, it's very similar to triangle sum theorem. All the third angles theorem is that if you are given two interior angles of a triangle, you can find the third. So in other words, if I have the triangle 1, 2, 3, all right, let's say that angle 1 was the one we didn't know. So these were the two that we were given. All that means is that you would take 180, subtract it from the sum of angle 2 and angle 3, and that'll give you the measure of angle 1. So it's basically the reverse of triangle sum theorem. It's what we already use when we're doing triangle sum theorem. It just actually has a proper name. Now, the next theorem comes into play when we talk about the specific types of triangles. But before we do that, let's actually classify some triangles. So, So remember, tick marks, it's a matching game. All right. So, looking at this first triangle, how would we dictate its angle? So we call this acute, obtuse, or right for the first triangle. So we don't know what this third angle is, but can we find it? Yeah. So real quickly, add up 30 and 89, subtract from 180, and see what this angle measure actually is. It's what? It's 119. So now does that help a little bit with dictating what type of triangle it is? So first off, if we classify it by the angles, what type of triangle angle-wise is this? Is it acute, obtuse, or right? Or equilateral? It's obtuse because it has that one obtuse angle. Now, if all three sides, so if all three angles are different, that automatically means all three sides are different. So that means this one would have 3 tick marks. So no congruent sides. So not only is it obtuse, it's an obtuse what type of triangle? Scaling. So that's how you go about naming a triangle. You look at the angles first. If you're missing an angle, use triangle sum theorem to find it, because sometimes it's not automatically acute, even though that looks acute. But remember, they don't always draw on the scale. All right? So don't judge it based off of what it looks like. In math, it's almost like court. It's innocent until proven guilty. In this case, it's innocent of not being acute until it's proven acute. All right. So look at this next one. Angle-wise, what would we call this triangle? Acute, obtuse, or right? Definitely a right triangle. We got that 90-degree angle. Now, based off of its size, what we call it scalene, isosceles, or equilateral? Scalene. Why? Right. None of the tick marks match up, meaning all 3 sides are different lengths. All right, what about the next one? So, based off of the angle, what we got? It's definitely obtuse because we got that 130. So as long as we got at least one obtuse angle, we can call it obtuse. We can stop there. Based off its sides. It's isosceles. Why? Right. There's 2 sides with 1 tick mark, which means we got those 2 congruent sides. So it's an isosceles. I always spell isosceles wrong. No, that's definitely not how you spell that. Isosceles. I could, but I'm too lazy to. Yeah, I spelled it right. No, yeah, I spelled it right for once. All right, now last one. It's equilateral. It's automatically equilateral. We can assume the angles are equal because all 3 sides are equal. So we don't have to call it anything fancy. We don't call it an equilateral. It's just equilateral. So guys, the great thing about triangles is there's always a connect. So if 2 sides are congruent, that means 2 angles are congruent. If 3 sides are congruent, that means 3 angles are congruent. If none of the sides are congruent, that means none of the angles are congruent. It balances. All right. You should always have the same number of congruent angles to the same number of congruent sides. All right. The last thing that we're going to do, and then we'll call it quits for today. Okay. So here's my challenge to you guys. Knowing what you know about angles now, I want you to work your way around to find this angle. So think about all we know about angles and triangles and all the theorems that we talked about so far today. Work your way around to get to that angle. This may use triangle sum theorem, this may use exterior angle theorem, this may use supplementary angles, this may use vertical angles. Everything that we know so far. And I'll give you a hint to get you started. What angle measure do you think I'm going to start at? I would start at the 45 and work your way down. So start at the 45, work your way down. You can talk to the things if you want.
So what kind of space?
Yeah.
So maybe like you have 45 and 6, you have
60.
Yeah, 68 minus 1.
I'm not going to say it.
You'll retire this way.
Look, you can ask my math readers last semester. They kept saying it, and that's only problem for homework they got. Right, when they stopped saying it,
Right, even say
not as soon but you're more work.
Are you trying to do one month? Because I will write this down.
We'll finish 2.2 with hospital search. I'll send you the notes. And they're also this one. That's the video.
How much?
And the videos and games.
Yeah.
All the 4 buttons.
Yeah. Ow.
So, straight line. All 3 of these. I'll read those angles I'll read these angles. Don't worry.
That's just coming.
Give you guys about 2 more minutes. I mean, I had braces in the middle. I had one for like 2 weeks. I got this right on my
Would you rather do launch? Like sooner?
I won the hospital in high school. I had teeth pulled. Oh my god, I'm so sorry. Think about it. All three of these angles are on a straight line. So if they're on a straight line, that means I have to add up to what? 180. So take that number, subtract it from 180, don't you this
What's it? What? The one that was.
the one here. You already did it. We just got to subtract 180.
That's what.
What are you gonna ask her?
But you said
Weren't you split down all the college?
That's what I thought. I thought they were gonna take it also. So my time.
All right, guys, let's come back together. All right, so. All right, so these are all the different angles that we could possibly find. All right, now I told you to start with the purple one, which is that 45-degree angle. So using that 45-degree angle, what color angle does that help me find?
oh, great.
It helps me find the green first. All right, so it helps me find the green first. What is the measure of the green angle? 45, they're vertical. All right, now that I have that angle within the triangle, what does that help me find? The red. How do I find it? Add them together, subtract it from 180. So what'd you get for that angle? 75. Now, a lot of you got to here, but then you were like, I have no clue what to do. So I talked it through with some of you. So remember, the next angle you're going to want to find is the orange. So remember, all three of those angles are on a straight line. Or a straight angle, if you want to go about that way. Which, what do we know a straight angle adds up to? 180. So can it not be said that all three of those angles will add to 180? Yes. So how would I find the orange angle? Subtract 68 and 75 from 180, which will give you what? Should give you what? 40. So 45 or 43?
Are you doing the 60 or the 68?
68. Okay, yeah. Now, this next part is just kind of whatever strikes your fancy. So, you do not have to find the blue angle if you don't want to. You could go straight to the black angle. How can I go straight to the black angle? What theorem could I use? It's one we've already learned. How can I, if I don't want to find the blue angle, how can I go straight to the black angle? Which is the one we're trying to find. So, ignore everything so far. You ignore everything that's on the left. What's that look like? We have two angles and what's this angle called?
I don't know what it's called. That.
Is it outside the triangle?
Yeah.
Well, where do we use for outside? There you go. It's an exterior angle. All right, so exterior angle theorem, which says what? If we add these two together, we'll get the black angle. So the black angle would be 143 degrees. Now, if you forgot about that, you could have used triangle sum theorem to find the blue angle. So what would the blue angle be? It would have been 37. So add up 143, subtract it from 180, which then, once you found the blue angle, these two angles are supplementary, so you would just have to subtract 37 from 180. It would have taken an extra step. It would have taken an extra step, but you could have done it that way as well. All right. So there's two ways you could have gone. You could have gone from the orange angle straight to the black, or you could have used the orange angle to find the blue, and then use the blue angle to find the black. Either way, you get the same answer. All right. So we're gonna call it for today. Now, here's what's gonna happen. So there is a new Delta math for you guys. All right. It's 2.1 and 2.2, but listen, you can't do all of it just yet. So you can do everything up to identify triangles. All right. Anything below identify triangles, you can't do yet. All right. So if you can get through the first 1, 2, 3, 4 sections, you're pretty good. All right. The rest of the time, you can work on any makeup work. I expect you to finish this part first. Now, that journal better be in that box by the end of this class. So if you haven't finished your journal, use that time to finish it now. If you did not finish your test yesterday, you're going to take all of your stuff and they're going to go down to Miss Davidson's room. If you did not start your test because you weren't here yesterday, you're going to do the same thing as well, but hold off because I actually can use the test. Right. So if you got to finish your test, go ahead, pack up your stuff, go down to Miss Davidson's room. If you need to start your test, come see me first, then you can pack up and go down to Miss Davidson's room. Quickly. Didn't you just go? Okay, yeah, you can go.